So I'm Mark Kachmarek, doing a technology update for Intel. I'm a strategic planner in our data center group. I've already had some opportunities to talk to you already at dinner last night and today. Looking forward to talking to more of you. As you get a chance, please come up and talk to me whenever you have a moment. So clearly, in the high-performance computing market, we are on the verge of many changes. You may say the environment is rapidly shifting. And I want to talk about some of the current trends and future trends that are driving that change and how Intel is looking to focus our investments to help people, our end users, get to their solutions, the problems they're looking at, with deeper insights faster. So, delivery. Up until now, typically high-performance computing has been in some data center and some on-site premise. However, we're starting to see a lot more people starting to look at the cloud. So the cloud service providers have started actually to focus on the HPC community and are providing now services and hardware focus for allowing real, true compute in those places. And with the advancement of containerization, more people now are starting to explore and play with high-performance computing in the cloud. Scope. So, up until now, the primary workloads have been modeling and simulation, and we're now starting to see where data-centric applications are becoming more of the norm in high-performance computing. In particular, high-performance data analytics and AI. And a lot of talk has already been happening about AI today, so I'm not going to go into a deep discussion about artificial intelligence. And scale. We are just a few short years away from a massive change in scale with the first exascale type class machines coming to the market. These are driving several changes already in the environment from the standpoint of users. As I said, cloud now opens up opportunity for lots of different users in high-performance computing. Typically it's been scientists and engineers at large universities, large labs, major enterprises, but now we are seeing small and medium-sized businesses starting to take advantage of high-performance computing because they have more access to that hardware and software capabilities, primarily driven from the cloud, but also as the technology is advanced and developed for our top community, it is now starting to move down to the smaller communities as well. New usages. Lots of new usages on the horizon. Precision medicine. I'm not going to talk in depth about these. In particular, I do have the opportunity to talk to some of the greatest minds in the industry about precision medicine, which are exciting when you really see what they're going to do. Automated driving, which is a really cool thing. Now that even I'm a fan, at first I'll say, why would I want a computer to drive me? But when you see all the technology can do, not only for us to free us in our mobility, but also improve the environment, automated driving becomes a no-brainer. And also, I guess, the killer robots. That was talked about earlier today. So, new models. We already talked about one of the new delivery models, that being cloud, but that is not the only model out there. Also, models in workloads, artificial intelligence, deep learning training being a new model, and new software models. So what is Intel doing to focus on our investments in this area? As you see, this slide is a perfect example of why use 6 slides. You can shove it all on one. But we're going to talk about what we're doing up in our architecture. So you already know about Scalar. This is our Xeon processors, which we ship today. Spatial, this architecture is best represented by our FPGA solutions in the market. And we have 2 new architectures that are coming to market shortly. This year we'll be seeing the introduction of our Nirvana neural networking processors for deep learning training acceleration. And Movius is already on the market, which provides small solutions, actually, that can be used for inferencing right down to your laptop. We also are developing quantum and neuromorphic. Neuromorphic best represented by Lohihi, which is our test vehicle that you can also use to see how brains actually work, kind of similar to how the brain neurons work in a neuromorphic compute fashion. So we are providing compute architectures that scale to all workloads. Not one architecture is best. We have several advancements that we are focused on in manufacturing. Clearly, you know about our processes, 10 nanometer in production today. We are also working on 7 and the 2 follow-ons beyond that. We have several advancements that we have in packaging. One we call EMIB, that's just an embedded interconnect bridge that helps connect 2 chips together, but it's very high speed, low latency interconnect. And technology known as Foveros. And Foveros actually allows multiple different technologies on different processes to be combined in the same package. So like, say, a 10 nanometer process and a 7 nanometer process chip, and others too, all in the same package. We continue to look at interconnects, and we do it in an open standard fashion. So the latest is Compute Express Link. We introduced that earlier this year. There is a consortium around Compute Express Link. It's not just an I/O. It's an I/O that also provides memory expansion capability as well as cache coherency capability. Very low latency, very high bandwidth. And again, this is an open standard. We developed the first initial spec, but now the industry is driving that. Software, we're looking at how do we improve the software environment. As I talked about earlier, we have a host of different architectures to solve your problems. Trouble is, we don't want you to have to use a host of different software environments to program each one of those. So we are looking at creating a more simplified environment. It's known as one API. It's actually not one API, and it's not an API at all. It's actually a concept of how do we create a single operating or a single programming environment that you can develop your code in, and then that code will compile to your targeted hardware. Be either a scalar CPU or maybe the new vector X to East architecture or an FPGA. Again, write once, compile to any targeted hardware. We continue to look at new advances in memory. Intel actually started as a memory company, and we still look at memory. Our latest is Optane that just came out earlier this year. So a couple years ago we introduced Optane, which is a very high speed, low latency memory solution, which is persistent in an SSD form factor, and that same technology is now in a DIMM form factor. So very high speed, persistent memory connected right next to your CPU. We also continue to contribute to Deos, another open standard, and security. We're looking at building security at every level of the products, all the way from our core, the CPU, to the SoCs we develop, all the way to the board and platforms and software. So for 2019, what are we looking at? So we have introduced our latest and greatest Xeon scalable processor. It integrates AVX512, which is an accelerator for deep learning, and it was an accelerator for compute. We actually developed that in our Xeon Phi processor and then moved it to our Xeon processor, so it is in wide use. We have Intel Deep Learning Boost technology. This is a fundamental platform we will be developing on over time for artificial intelligence. So optimized code, or I say optimized hardware in the CPU to accelerate AI codes. This first one being for inferencing. And expanding memory bandwidth. So not only just through more channels, but also through new technologies such as Optane. We're also looking at optimized tools and libraries. I've already talked about what we're looking at from a one API standpoint, but we have a host. We have somewhere on the order, I think 10,000 software engineers. Is that right, Tom? Is it more? 15,000 software engineers at Intel who will do a host of activities from compiler work to our advisor solution, our MPI libraries, MKL, and that's all being played into, as I said, our One API initiative going forward. Earlier this year, we just introduced our latest Xeon Platinum 9200 series product. This makes use of our newest advancements, so it's 2x faster than our prior generation in compute, has up to 56 cores. And as I said, it also is being advanced. All our CPUs going forward have advancements for artificial intelligence, a key new workload. You can see deep learning boosts about a 30x improvement in inferencing workloads versus our prior generation. And then a peek into the future, we talked about Aurora, the next exascale machine that will be coming out soon. It'll make use of our newest architecture, X to the E. This is built on 7 nanometer process. It'll make use of our latest packaging capability known as Fervoros, and it'll be a key element in the Aurora supercomputer being installed in 2021.